A very warm welcome to all of you. Myself, Professor Nagreses from Department of Chemistry, KG Somaya College, Kopargaon. In this lecture, we are going to study the new important topics that are first important topic is a classification of electrodes and second one is liquid junction potential. These two important topics we are going to study in this lecture. Before starting this lecture, please subscribe my YouTube channel and press the bell icon in order to get the notification for the upcoming video lectures. So let's start this lecture. We know very well the electrodes. Now as far as the electrode is to be considered, we are interested that what are the different type of the electrodes are to be there, how these electrodes are to be classified depending upon the different type of the natures of the metal to that of the salt solution or the state of a particular electrode. So depending upon that, these are the five important classes of the electrodes. The first one is metal ion electrodes, second one is amalgam electrodes, third one is a gas electrodes, fourth one is metal insoluble salt electrodes, and the last one is oxidation reduction electrodes. These are the five important types of the electrodes. Let us look towards these electrodes one by one. The first important type of electrode is metal ion electrodes. Now, how this electrode is to be formed and what are the simple examples of this type of the electrodes? This type of electrode consists of a rod or a strip of metal deep in a solution containing its ions. Thus, a metal is in equilibrium with its ions. In order to form these type of the electrodes, we have to take here either a rod or a strip of metal, and that rod or a strip of metal we have to dip in such a type of the solution containing its ions. So in this case, the metal and metal ions are in an equilibrium with each other. These electrodes are represented by the following general reaction. Metal, it gives the Mn plus N electron. This is a general representation of this type of the electrodes. Now, if we want to study a specific example of this type of the electrodes, let us consider here a zinc electrode in solid state. It gives Zn2 plus 2 electron, and next one is a copper in a solid state. It gives the copper 2 plus 2 electron. We can say that in these examples, metal is here zinc as well as this copper is there. This zinc and copper are in equilibrium with their metal ions, that is zinc is in equilibrium with this Zn2 plus and this copper is in equilibrium with the copper 2 plus. That's why this type of the electrode is called as the metal ion electrodes. The next important type of electrode is amalgam electrodes. In some cases of metal ion electrodes, the pure metals are too active to use them in aqueous solutions of their ions. In case of a metal ion electrodes, if we use the pure metals, they have so much activity or they are too active to use them in a aqueous solution of their ions. To avoid this, in such cases, these metals are used in the form of their mercury amalgams. So these electrodes are called as the amalgam electrodes. In order to take into consideration the higher activity of these pure metals, we have to use these metals in the form of their mercury amalgams, and that's why these electrodes are called as the amalgam electrodes. These electrodes are represented by the following general reaction. Metal with that of the mercury, that is a metal amalgam, it gives Mn plus N electron. If we look toward the specific example, this is a K along with the Hg, that's why it is a potassium amalgam, it gives the K plus 1 electron. If we use the second type of electrode, it is a sodium amalgam, it gives the Na plus 1 electron. So this is the second important type of electrode called as the amalgam electrodes. The third important type is a gas electrodes. These electrodes are usually constructed by a platinum foil or platinized platinum foil is kept immersed in the solution and the gas is bubbled around it so that the foil is fully saturated with adsorbed gas. In this case, we have to use a platinum foil, a platinized platinum foil that we have to immerse in a particular solution, and surrounding this foil we have to immerse, we have to bubble a gas. That's why it gets saturated with a particular atoms of gas. The important examples of this gas electrode is, first one is platinum, H2, vertical line HCl in a aqueous form. In this case, we take here one inert metal electrode, inert metal, that is platinum. That's why this electrode is called as a hydrogen gas electrode. The second one important example of this electrode is a platinum, Cl2, vertical line Cl in aqueous state. So this is a second type of gas electrode, that is called as the chlorine gas electrode. The fourth important type of this electrode is a metal insoluble salt electrode. This electrode is constructed from a metal in contact with one of its sparingly soluble salt and a solution containing the ion present in the salt other than the metal. The name itself indicates, in order to construct this type of the metal, we have to take a particular metal which is in equilibrium with one of the insoluble salt. For example, if we take here silver as a metal, we have to take here its salt as a silver chloride electrode. This is to be represented as Ag vertical line AgCl in a solid state, vertical line Cl minus, that is the activity of Cl minus. The second one important example is a silver bromide electrode, represented as Ag vertical line AgBr in a solid state, vertical line Br minus, in which the activity of Br minus is here. This is a fourth important type of an electrode, metal insoluble salt electrode. The last important type of this electrode is oxidation reduction electrode. The electrodes in which the ions of a substance in two different oxidation states are present in a same phase. This type of the electrodes in which the ions of a substance is present in a two different oxidation states and they are present in a same phase. So this type of the electrodes are called as the oxidation reduction electrode. The platinum wire is used to facilitate the exchange of electrons from one species to another and provide electrical contact to the electrode. In this case, always a platinum wire is used for the electrical communication. The important examples are, if we take into consideration here, the iron, this Fe is present in a two different oxidation state. One is Fe2 plus, it get converted into Fe3 plus. They are in equilibrium with each other. That's how we can say that Fe2 plus undergo oxidation to form Fe3 plus. That's why in this reaction, two type of the reactions are involved. One is oxidation, the second one is a reduction. That's why it is a oxide, that is oxidation reduction, or it is a redox reaction. The second important example is a cerium 3 plus converted into cerium 4 plus with evolution of one electron. So this is the fifth important type of electrode, oxidation reduction electrode. So these are the different types of the electrodes depending upon the different combination of metal with that of its particular salt solution. After studying this type of the electrodes, we are going to study now next important topic, liquid junction potential. What is the meaning of liquid junction potential, how it is generated, and how to minimize this liquid junction potential. Consider an electrochemical cell in which two electrodes are there, zinc and copper. Zinc vertical line zinc sulfate solution, vertical line copper sulfate solution, vertical line copper. In such a type of a cell, two different solutions come in contact, due to which liquid-liquid contact develops. In such a type of the cells, two different type of the salt solution is there. One is a zinc sulfate solution, second is a copper sulfate solution. They are in a direct contact with each other, and that's why there is a liquid-liquid contact develops. At the junction of two liquids, a potential difference is developed, which is called as the liquid junction potential. Due to the direct contact between these two salt solutions, there is a generation of potential can be takes place. Then such a type of the potential at the junction point is called as the liquid junction potential, which is represented by EJ. This potential difference develops due to formation of electrical double layer at the junction of two liquids. This potential is calculated by using the following relation. Before look towards this relation, keep the one important phenomena takes place in this case. Whenever these two type of the solutions are present in a direct contact with each other, potential difference is generated, and this potential difference is generated due to the formation of the electrical double layer at this step of the junction point, and that's why this step of the potential is to be generated. This potential is to be calculated by using this type of the relation. Cell potential is equal to potential of left hand electrode plus potential of right hand electrode plus this is a liquid junction potential. The liquid junction potential has, now in this case, the liquid junction potential, if you want to calculate, it is to be calculated after knowing the cell potential as well as the magnitude for potential for left hand electrode as well as the potential for right hand electrode. If we know all these three parameters, we can easily calculate the liquid junction potential. The liquid junction potential has always been eliminated or minimized by inserting a salt bridge between the solutions of the two electrolytes. Now the question arises, whenever we want to minimize or remove this type of the liquid junction potential, what we have to do? So at that situation, we have to use a salt bridge for construction of a particular cell, and due to the use of this salt bridge, this type of the direct contact between these two salt solutions are restricted, and that's why this potential, liquid junction potential, either get minimized or we can remove also. So this is an important point called as liquid junction potential, its meaning, its development, its calculation, and how to minimize this liquid junction potential. So in this lecture, we studied the two important points. First one is the different type of the electrodes, and the second one is liquid junction potential. So with this, I stop here. The remaining points of this chapter we will study in a next lecture. So thank you so much.